Hi guys. So I'm in the lab and I'm going to start doing the acid and base lab that you guys would have done if you would have came to a face-to-face laboratory this week. So the lab we're going to do starts on page 83. Okay, looks something like this in your lab manual. Okay, and what you need to concern yourself with starts on the data table, which is on page 87. Okay, so as I go through each part, I'll tell you what part I'm doing, and then you will record the data. Okay, so I'm going to start with part 1. Okay, this is part 1. This is called acid and base classification. Okay, so just bear with me because I'm kind of doing this one-handed. So, acid and base classification. So what I have here is I have some bottles. I've got strong acid, I've got neutral, I've got strong base, I've got weak acid, and I've got a weak base. Okay? And what I'm going to do is I'm going to take each one of these bottles and I'm going to put it onto one of these pieces of pH paper. And what you need to record on your data table is you need to tell me the color that it turns. So that's all we're looking for. So the first one, strong acid. Okay, so all you need to tell me is what color does the pH paper turn. And I tried to put this on a piece of white so that you could kind of see it better. So all you got to tell me, what color is that? Okay, and I'm not going to grade based on, oh no, that's not what color I think it is. Okay, second one, I got weak acid. Okay. Okay, now we're going to do our neutral. Now we're going to do our weak base. So you can kind of see a difference between neutral and weak base. Okay, and then we're going to do our strong base. So you can kind of see those. Okay, so that is part 1. Okay, part 2 over here. Okay, so part 2 is called acid and base identification. Okay, so I'm going to do the same thing, but I'm actually going to go with your data table and I'm going to put a drop of a known acid or base onto a piece of pH paper. Okay, so the first one I'm going to do is hydrochloric acid. So hydrochloric acid onto this piece of pH paper. Okay, so first thing you're going to do is tell me what color do you think that is. Okay. Second thing you need to do is you need to tell me what pH number it is according to this chart. So you need to compare that to this. Okay. Now you will look at, and I'm just going to do this once, you're going to look at whatever you put here, you're going to look at this. So whatever range your pH number is in tells you if it's a strong acid, a weak acid, a strong base, a weak base, or, well, you're not obviously going to have neutral, but, okay, so if your pH was between a 0 and a 3, then it would be strong. If it's between a 4 and a 6, it would be weak, okay? Okay, our next one is sulfuric acid. Sulfuric acid, right, sulfuric. Now, if some of these are the same, that is okay, not a big deal. Okay, what color is this? Okay, whoop. Based on this color, what pH do you think this is? Okay, acetic. Okay. Got our bases next. Got potassium hydroxide. I'm trying to get some good light here for you because it's hard to. It's one or the other. Pick which one you think it is. Okay. Then we have let's see, sodium hydroxide. Okay. Again, it's kind of hard to see this, huh? Use your best judgment. Okay, and our final one is ammonia hydroxide. Let's see, it's ammonia hydroxide. So you can see that this is obviously not a blue this time. It's more of a green. So which green do you feel that it is? Okay. Very good. Okay, so that's the first part. You can see the differences between the two, those. Okay, so our next part, we're going to walk over here. Our next part is reaction with metals. Okay, so some of the intro stuff, acids will react with certain metals. Okay, so I'm going to show you. So this part, I'm going to try to do the best I can with this. Okay, so I've got 3 test tubes here, and I'm going to add the iron last here. So in the first test tube, I have, this is magnesium, okay? This has some zinc in it, and I'm going to add some iron here to this last test tube. So we can get some in there. You don't want to add a whole lot of iron because it makes it hard to see what's going on in the test tube. I'm just going to add a little bit, okay? Now I'm going to add 5 drops of hydrochloric acid. If you can see this back here, it's HCl. I'm going to add 5 drops of hydrochloric acid to each one of these. And what you're looking for is you're looking for some type of reaction. You're looking for bubbles, okay? So I want you to watch closely. Okay. You can probably even hear that one. You can see the gas coming off of it. Okay, so again, that is the magnesium with HCl. Kind of go over to these two because they're a little harder to see. Shake them up a little bit. These two, you're going to kind of let them sit there for a second. And what you're looking for is you're looking for movement. I know I can see some on this one. And I can see a little bit of movement in that second one. Okay. So now I'm going to go over these ones. Okay, so this is the same thing. We've got magnesium. We've got some zinc. I'm going to add iron to this last one. Okay. And I'm going to add some base. This is KOH, potassium hydroxide. Okay, and again, you're looking for bubbles. Let that sit for a second. And I don't know if you can tell, but it is not doing anything. Alright, so we have HCl with metals, which are obviously reacting. And we have potassium hydroxide with metals. It is not doing anything. Okay. Our next experiment involves looking at a naturally made pH indicator. So this morning I came in and I made cabbage extract by boiling red cabbage leaves. And by boiling red cabbage leaves, I'm left with, I don't know if you can see, there's like a purple, water. So the dye comes out of the purple leaves and you're left with a naturally made pH indicator dye. So what you're going to do on part 4 is you're going to tell me what color the indicator dye changes the specific acid or base. So on these first 3, I'm going to put the acids. So for this first test tube, I'm going to add 10 drops of hydrochloric acid. Okay. Second test tube is going to have sulfuric acid in it. So these already have the cabbage extract indicator in them. Okay. And this third one, we're going to add acetic acid. So these are all my acids with the cabbage extract already in there. Okay. So you should be able to look at those and see what color they change. I don't know if I can put, see, they are a different color now. I apologize for my phone. Okay. These have the indicator already in them, and I'm going to add the 3 bases. So I'm going to start with potassium hydroxide in this test tube. Woo. Okay. I'm going to put sodium hydroxide in the next test tube. Very green. And I'm going to put ammonia hydroxide in this last one. Also a green color. It's not as green, but it's still a green color. I can get a white piece of paper back here for you so you can see. They are a green. It's kind of a mint green. Not this one. Okay. So when you add acids and bases with cabbage extract, you either get acids turn pink, bases turn like a yellowish green. Okay. The next thing we're going to do, which is part 5, is called neutralization of acids and bases by titration using the cabbage extract indicator, which is a big, long, scary sentence that everybody starts panicking over, and they really don't need to panic over. It's basically saying that I'm going to neutralize an acid and a base and make a salt and water solution by titration, which means I'm going to add them a drop at a time, and I'm going to use the cabbage extract as my indicator dye. Okay, so to start this off, I've already got my cabbage extract in this one. Okay, so I'm going to put 10 drops of sodium hydroxide into this. Okay, so you can see that it is a green color. All right, you guys can see that. Okay, so titration means I'm going to add 1 drop at a time of acid until this neutralizes. And when it neutralizes, there's a complete color change. And when there's a complete color change, that means that there is salt and water that is left. So I'm going to add 1 drop, mix it, it didn't change. I'm going to add another drop, mix it, still didn't change. Okay, here's my 3rd drop. Not really. Here's 4 drops. A little bit. Here is 5. A little bit. 6, 7. I didn't mean to do that, but so can you see the complete color change? Look at that. No longer green, it's clear. So it took me 7 drops to go from clear, or from green to clear. So our initial color was, our final color is clear, and how many drops did it take us to get to that? Okay. Our next part, we're going to do this with a naturally made pH indicator. So I'm going to start with 10 drops of potassium hydroxide. 2, 3, 4, 5, 6, 7, 8, 9, 10. Whoops, one to grow on. Okay, and I'm going to add, this is called phenolphthalein. Okay, so this is a chemically made pH indicator. Cabbage, naturally made. Okay, add 1, 2. And we'll do 1 more to grow on. Okay, so see how pretty pink? Alright, very pretty. Okay, so now I'm going to add HCl, and this is again a titration. I'm going to add 1 drop at a time, and when this changes completely, that means it's neutralized, and what's left in my test tube is salt and water. So, do this.